It's official. We now know the exact location and timing of the Yellowstone supervolcano's next eruption, and it's called a supervolcano for a reason. It will be thousands of times more powerful than a typical volcanic eruption. When this happens, the planet will face massive disasters. Earthquakes, tons of magma flows, ash and clouds that will block out the sun. The sky will be gray for a long time. We will have a shortage of food because of the lack of sunlight. Planes won't be able to fly. Some species of animals and trees may disappear. One disaster will follow another, like falling dominoes, one by one. Terrible times await Earth, and okay, stop. It's clear, we got it. But when will all this happen? Don't worry, you won't be left without an answer. When ordinary volcanoes erupt, it's always a disaster, but only for those places that are located near the epicenter. Multiply the damage from an ordinary volcano by thousands and you'll get a supervolcano eruption. Yellowstone is one of the largest volcanic systems in the world. It's erupted 3 times in the last 2.1 million years. The last time was 640,000 years ago. The ash covered an area comparable to about half of the United States. Fortunately, there were no people there, but nature got hurt. A similar eruption of a similar supervolcano occurred about 74,000 years ago. It was the Toba supervolcano in Indonesia that caused an apocalypse the human race barely managed to survive. According to some theories, only a few thousand people stayed alive at the time during the volcanic winter, but it's not confirmed. Since Yellowstone is a volcanic system located in a vast national park, it was important for scientists to find out exactly where the first spark would come from. They found out that Yellowstone's magma doesn't accumulate in one place, but hides in several separate underground reservoirs. The reservoir in the northeast of Yellowstone, next to a beautiful place called Sour Creek Dome, is the riskiest. Here, the red-hot magma comes into contact with the hot rocks of the mantle, which are located deep in the ground. Their high temperature keeps the magma in a liquid state. Imagine that you put a pot of hot milk on the stove. Nothing cools down, but only gets hotter, so the milk may soon begin to rise and flow out of the pan. The same thing is happening with the magma under Sour Creek Dome. Magma doesn't cool down there, and at some point it may start to come out. It'll be like a broken pipe from which a fountain of boiling water gushes. But how did scientists find out? The magma reservoirs are located at a depth of about 6 miles, and this whole area is incredibly hot. They used a special method called magnetotellurics. So, Earth's rotating core creates a magnetic field that surrounds our planet. Magma flows around the core, and it contains many magnetic minerals that also create magnetic fields. Scientists use special instruments that sense those fields emanating from the magma, like a metal detector senses lost jewelry on the beach. Using magnetotellurics, they scanned Yellowstone and discovered 4 large magma reservoirs. 3 of them emitted powerful electromagnetic waves, and in the 4th, which is in the northeast, they recorded a much stronger signal from the magnetic field. This is where the eruption is supposed to occur. But fortunately, it won't happen soon. Perhaps in tens of thousands of years, perhaps in hundreds. Phew, you can relax. No volcanic apocalypse is coming soon. But how do scientists know when this magma will start to erupt? Magma doesn't have a timer, and the volcano doesn't wake up with an alarm clock. So, magma flows inside the pores of solid rock. It resembles a dishwashing sponge with lots of small holes through which water passes. Magma penetrates these pores and fills them. For magma to start erupting outward, it must fill at least 40% of these pores. About 20% of them are filled now. But these hot rocks continue to heat the magma and keep it liquid, so it can flow between the pores. At some point, it will connect with other pools of the liquid magma and become a large stream that will rise to the top. How can we prevent this from happening? It seems that the solution here is to cool the balsam rocks, but it's impossible to do so. They are several miles deep, they are incandescent, and there are too many of them. And in any case, trying to cool a part of the Earth's core sounds like a very bad idea. All we can do is accept that nature has its own plans. If the eruption occurs in tens or hundreds of thousands of years, then perhaps humanity will find a way to solve this problem. If not, then we should prepare for the consequences. A huge global catastrophe starts with a massive, large-scale explosion. The erupting magma produces a gigantic amount of ash. A powerful burst of energy collapses the Earth's crust over the magma reservoir. This leads to the formation of a giant caldera. You've probably seen a huge crater in a volcano. So, this is the caldera. The natural disaster is so loud it deafens everyone who's nearby. The blast wave rises ash and pumice stone at a speed exceeding the speed of sound. Volcanic materials reach incredibly high altitudes in minutes. Then, this pillar of ash spreads and plunges a huge territory into darkness. The incandescent particles in the lower part fall under their own weight and heat the air around them. It's almost impossible to breathe. The red-hot pieces of pumice stone and ash set fire to the surroundings. All this hot mass turns into pyroclastic flows that destroy and burn everything in their path. Forests, houses, roads, everything turns into coal. No planes can fly there. Tiny particles can penetrate engines. Besides, it's impossible to see through such a dark gray, hot cloud. It's also dangerous to drive cars. Volcanic particles can burn tires. Luckily, thanks to seismic technologies, people have learned in advance about the eruption, so everybody has evacuated. The column of ash that has reached the edge of space continues to expand in different directions. The wind helps the volcanic dust expand. A giant umbrella-like cloud appears over the territory of Yellowstone. It's getting wider and wider and plunges a huge area into hot darkness. During the first 24 hours, ash falls on most of the United States and parts of Canada. It knocks out power lines, pollutes bodies of water, and destroys crops. Then, the rains begin. The water mixes with the ash and falls to the ground in the form of gray mud. And don't forget, it's also poisonous. The ash contains mercury, arsenic, and lead in large quantities. Such toxic masses poison rivers, lakes, land, and air. All this time, the volcano continues to erupt. The outbursts of magma, ash, and pumice can last for several weeks or even a month. And this is just the beginning. The ash soon begins to settle, but the sulfur dioxide released during the eruption spreads all over the atmosphere. This gas mixes with the atmospheric water vapor and forms an aerosol consisting of small particles. All this covers the planet like a veil. This cap makes it difficult for the sun's rays to pass through, which means it lowers the temperature of the Earth's surface. These events cause a sharp cooling of several degrees in the world. Farmers lose a huge amount of their crops. Food prices rise and economies collapse. There might be a famine all over the planet. Human civilization can plunge into chaos. In a few years, the temperature will start rising, but it will take at least a couple of decades to return to previous standards. What will become of humanity by that time? Of course, we will survive, but we'll have to rebuild our civilization. But don't be afraid. If nothing depends on us, let's just enjoy every day of life. Be grateful and help each other. Supporting and caring for each other even during the volcanic winter is a guarantee that humanity will survive.
It was April 2025 when geologists went back to Yellowstone's Norris Geyser Basin for the first time this year. And while doing their usual check, they realized that something was different this time. Where there used to be just a boring patch of ground, now there was a giant hole, about 13 feet wide, filled with weird, milky, light blue water. Everyone was terrified. Was it the sign that the Yellowstone supervolcano was ready to erupt? If so, it would be a worldwide disaster, the kind that destroys cities. According to the U.S. Geological Survey, if such an eruption occurred, the after effects would be felt all over the world. To start, the areas immediately surrounding Yellowstone would experience pyroclastic flows. That's the lava that erupts out of a volcano, including a high-density mix of volcanic gas, ash, pumice, and hot lava blocks. Those flows would destroy everything they touch, and an eruption of Yellowstone would send them into Wyoming, Idaho, and Montana. Areas further away from Yellowstone would escape the flows, but they would experience falling ash. It would come down heavily in the states closest to the epicenter. The ash would be especially dangerous for anyone breathing it in. The weight of the ash would also pose a serious threat. It would smother crops and collapse buildings as it piles up. Tragic consequences would be countless, but we'll talk about them later, because soon after the discovery, the weird pit surprised even experts. Geologists found rocks scattered everywhere. Some were about a foot across, and all of them were dusted with gray mud. This mud matched the walls of the new spring. It was like the place had simply exploded, but nobody had actually seen it happen. The team checked old satellite images to figure out when it appeared. In December 2024, the ground was totally normal. By January 6, 2025, a little dip had formed. And by February 13th, that water-filled hole was finally there. But the weird thing was that the sensors that usually pick up major hydrothermal explosions didn't detect anything. There was no giant blast or warning signs. Later, it turned out that this puzzling opening in the ground hadn't just popped up in one huge explosion. Instead, it formed from a bunch of smaller bursts over time. Little explosions first threw out rocks, then mud, and eventually created the pit. With time, it filled with silica-rich water. That was a huge relief for everyone. Yellowstone sits on a supervolcano, and its big explosions are a nightmare scenario. Luckily, this time, it was just a slow-building, small-scale explosion. It was dramatic, sure, but totally manageable. You see, Yellowstone National Park is full of geysers, hot springs, and all kinds of natural landscapes. But under the surface, things get incredibly intense, all because of the supervolcano. Now, supervolcanoes are often extremely large. They often have no cone at all, since they're typically the remains of gigantic magma chambers. Once, those chambers flared up, leaving behind a caldera. They're usually located over hotspots. It's no surprise that supervolcanoes can produce supereruptions, and when they do it, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 supereruptions could fill the Grand Canyon to the brim. Supervolcanoes form when huge volumes of scorching hot magma escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. So, a pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more and more magma is trying to get to the surface. And then, bang, a supereruption occurs. Now, back in 2015, researchers at the University of Utah mapped out the main magma chamber of the Yellowstone supervolcano and were shocked by its size. And then, they found another one below it. Together, these underground magma pools could hold enough molten rock to fill the Grand Canyon 11 times. All that magma pushes up on the ground above, which is why Yellowstone rises about an inch or two every year. That slow lift might not sound like much, but combine it with the fact that Yellowstone is still an active volcano and has a volcanic explosivity index of 8, and it's enough to make you wonder what could happen if things went south. And yes, Yellowstone has indeed been a bit jumpy in recent years. In March 2023, there were 354 earthquakes in the area. Most were tiny, but the biggest hit a magnitude 3.7, part of a swarm of 106 quakes. Now, before you freak out, experts from the Yellowstone Volcano Observatory say there's no need to panic. No eruption is coming anytime soon. Volcanoes don't stick to a schedule. Just because Yellowstone hasn't erupted in a long time doesn't mean it's about to blow. The park is stable for now, but scientists are keeping a close eye on everything underground, the quakes, the rising ground, and even temperature changes, just to be safe. The superhot plume of magma, a hotspot under Yellowstone, has been churning for 17 million years. The Earth's crust slowly moved over it, making the hotspot leave a trail of volcanoes stretching more than 450 miles along the Snake River Plain. Most of those ancient ones are now buried under layers of lava and sediment. In just the past 2.1 million years, Yellowstone has unleashed 3 cataclysmic eruptions, so massive they managed to reshape the land. Each explosion sent pyroclastic flows, rivers of searing hot rock, ash, and pumice racing outward for miles. The debris piled up in layers hundreds of feet thick, some forming solid lava-like rock. When those eruptions emptied the underground magma chambers, the roof collapsed, forming the massive calderas we see today. Even after those mega eruptions, Yellowstone didn't stop. Between 180,000 and 70,000 years ago, enormous rhyolite lava flows, sometimes over 144 cubic miles, poured out. Some flows followed north-south vent lines. The West Yellowstone flow erupted around 110,000 years ago. The Nez Perez Creek flow followed 160,000 years ago. If you stand at Madison Junction on the caldera's northwest rim, you can see it, a cliff that formed when the Lava Creek Tuff eruption collapsed the land 640,000 years ago. And inside the caldera, you'll see the hardened lava flows snaking across the floor. Figuring out when a supervolcano might blow is like being able to read nature's warning signals. Thousands of years before a massive eruption, the heat underground starts building, and the magma chambers become like ticking pressure cookers. Little signs start showing up. Gas bubbles escape as the pressure shifts, and earthquakes shake the ground. The land above slowly rises. Cracks appear. Hot springs and geysers start acting up, heating even more than usual. Now, what would happen if Yellowstone erupted? Remember those pyroclastic flows we talked about before? They can contain 2 parts: the lower flow of the hot lava that moves at ground level, and a cloud of ash that follows above the lava level. So the 2 of them would devastate huge areas. The ash would even reach Europe within 3 to 4 days of the eruption, but it wouldn't be so bad there. After that, it would only take around 2 to 3 weeks before cooler temperatures set in around the globe, all thanks to the sulfur gas that would get to the upper atmosphere after the eruption. Scientists predict that global temperatures would drop by up to 10 to 12 degrees. These consequences could last for 6 to 10 years, putting an end to monsoons, which could cause widespread famine in Asia. Scared? Well, don't be. The good news is that scientists don't believe that the sleeping giant under Yellowstone National Park will wake up in our lifetime. Experts say the next Yellowstone eruption won't likely happen for hundreds of thousands of years. And even then, it may not be that bad, because scientists have discovered that the magma lurking within Yellowstone is actually split up amongst 4 different chambers. Not only that, but some of the reservoirs of magma are likely to cool down and solidify, lessening the chances of an eruption. So, while an eruption does sound like it would change the landscape of the world, it's very unlikely to happen anytime soon. So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's the reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the two reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha, loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Pollan claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Pollan and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster. Park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone Caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning. A burp, maybe? But that long ago, there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot expanding gases. It looked like an extremely hot toxic snow avalanche. With a temperature of about 1,300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sunblocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate.
There's an old volcano in Bolivia called Uturuncu. It hasn't erupted in about 250,000 years, so you may think that's the end of its story. But recently, it has started to act a little strangely. At the moment, it resembles a zombie that's waking up from a long nap. Uh-oh, is that kind of apocalypse nearing? Uturuncu is a huge mountain in the Andes that's almost 20,000 feet tall. It's called a stratovolcano, which means it's big, steep, and cone-shaped. These kinds of volcanoes are made from layers of lava, ash, and rocks. They can have terrifying, powerful, explosive eruptions because their lava is thick and traps gas inside. Think of it like a shaken-up soda that's ready to burst. Famous ones like Mount Vesuvius are just like Uturuncu. And do you remember about the tragic fate of Pompeii, completely destroyed during the eruption of Mount Vesuvius? Does something similar await Bolivia? Even though Uturuncu has been quiet for a long time, scientists have noticed that it's been letting out gas, rumbling with small earthquakes, and even making the ground around it bulge, kind of like it's stretching. So, people started wondering if it was getting ready to erupt again. Scientists decided to take a closer look at this situation and found out that liquid and gas moving around under the volcano is causing all this activity. It doesn't mean the volcano is definitely going to erupt, but it helps explain why it still seems alive. Let's dive into details. Since the 1990s, scientists have been using satellites and GPS to keep an eye on the ground around the Uturuncu volcano. At one point, they noticed something weird. The ground was rising in the middle and sinking around the edges, kind of like a sombrero hat. The middle part has been slowly going up for at least 50 years, by about 0.4 inches a year. It doesn't sound like a lot, but hold on. This strange shape, along with lots of tiny earthquakes and gas like carbon dioxide coming out of the volcano, made scientists think that there might be a giant blob of magma growing under the mountain. If that were true, it could mean only one scary thing. The volcano could be getting ready to erupt. Uturuncu sits on top of a huge underground pool of magma called the Altiplano Puna magma body. This pool is really big and really deep, stretching under parts of Bolivia, Chile, and Argentina. Scientists thought that magma from the APMB might be rising and collecting near the surface, which could lead to an eruption. But now, after studying more than 1,700 earthquakes and checking the rocks around the volcano, scientists have a new idea. Apparently, it's not magma rising up. Instead, hot fluids and gases are traveling up from the APMB through a narrow path shaped like a chimney. These gases, like steam and CO2, can get trapped under the top of the volcano, while salty water, brine, spreads out sideways into tiny cracks in the rocks. This moving gas and water can make the ground rise and fall and cause small quakes, without any magma getting close to the surface. So the good news is, Uturuncu probably isn't about to erupt. If it did happen, it would cause serious damage to nearby communities and even pose a threat to human lives. Lava flows could reach towns tens of miles away from the volcano, and volcanic ash could even spread across Bolivia, Argentina, and Chile. Luckily, even though the volcano is still alive and rumbling, it's not as dangerous as scientists once thought. This discovery might help scientists figure out if other volcanoes around the world are getting ready to erupt. Now, let's visit Alaska, where according to researchers, Mount Spur might erupt soon. It's letting out strange amounts of volcanic gases from the top and side vent, the very vent that last erupted in 1992. If it erupts again, it could cause problems for airplanes flying nearby and might send ash falling from the sky. The good news is that nobody lives close to it, so people are safe for now. But even though Mount Spur isn't super dangerous, there are other volcanoes around the world that could be really destructive. One of those is Campi Flegrei, a giant volcano system near the city of Naples. Instead of one big mountain, it has 24 craters spread across the area. It last erupted in 1538, but its biggest eruption happened about 40,000 years ago. That explosion covered the whole Mediterranean region in ash and made temperatures drop by up to 16.2 degrees Fahrenheit in Eastern Europe, which led to a very cold volcanic winter. If Campi Flegrei erupted again today, it could be very dangerous. It might cover Naples and nearby places in ash, causing earthquakes and landslides, and create air pollution and acid rain. Scientists are keeping an eye on it, especially after a 4.4 magnitude earthquake shook the area in March 2025. But the good news is there's no sign that magma is rising to the surface right now, which means an eruption isn't expected soon. Still, since Italy has a lot of volcanic activity, experts continue to watch it carefully. Mount Vesuvius is also in Italy and is one of the most famous volcanoes in the world. It's known for its huge eruption in 79 CE that buried the Roman cities of Pompeii and Herculaneum. The last time the volcano erupted was in 1944. Today, Vesuvius is even more dangerous because over 3 million people live near it. Around 700,000 people are living illegally right on its slopes, which puts them even more at risk. If the volcano erupts again, it could send rocks and ash flying through the air at nearly 100 miles per hour and cause major destruction, possibly even wiping out Naples. And still, scientists believe a big eruption from Vesuvius probably won't happen for a few hundred more years. But since it's still an active volcano, researchers continue to monitor it. Cumbre Vieja is a volcano on the island of La Palma, which is part of the Canary Islands. It last erupted in 2021. During that eruption, lava poured out of the volcano and flowed all the way to the sea. It destroyed over 3,000 homes, but luckily, thousands of people were safely evacuated, so it wasn't as bad as it could have been. In the past, scientists were worried that a huge eruption could cause the entire western side of the volcano to break off and crash into the ocean. This could create a mega tsunami, sending massive waves hundreds of feet high across the Atlantic Ocean. But more recent studies have shown that this is very unlikely to happen. Mount St. Helens is a volcano in Washington State in the United States. It had a massive eruption in May 1980 that ended the lives of 57 people. That eruption also caused the biggest landslide ever recorded. Hot, pressurized magma exploded from the volcano, shooting ash 15 miles into the sky. Ash covered a huge area, and around 230 square miles of land was destroyed. Mount St. Helens is still active and is expected to erupt again someday, possibly even in our lifetimes. But experts say it's not likely to have another huge sideways blast like the one in 1980, thanks to a deep crater that is now formed at the top. It will change the way the volcano might erupt. Popocatepetl is a big, active volcano in Mexico. It's been slowly erupting on and off since the early 2000s. It's really close to a lot of people, just 40 miles from the Mexico City metropolitan area, which has about 22 million people, and 30 miles from Puebla, which is home to about 6 million inhabitants. If Popocatepetl had a huge eruption, it could cover Mexico City in thick ash as much as 8 inches deep. That ash could block drains, mess up the water, and even stop the electricity from working. Even worse, fast-moving lava and super hot flows, called pyroclastic flows, could rush down the mountain and destroy towns nearby. The volcano was quiet for 50 years, but now it rumbles and shakes pretty often. There have been over a dozen small eruptions, including some as recent as February 2024. Some nearby places got covered in ash, but scientists say this isn't too surprising, and they're keeping a close eye on it.
So, you notice anything weird? Recently, there have been alarming changes in the water levels in different parts of Yellowstone Lake. At the same moment, the water level can be rising on one side of the lake and falling on the other. Ooh, it looks as if the lake basin gets lifted by some underground forces. Can it be a sign of a looming disaster? Geysers, mud pots, and hot springs turn Yellowstone National Park into some extraterrestrial world. And all these wonders are fueled by a mighty supervolcano. Supervolcanoes produce supereruptions. When it happens, they launch more than 240 cubic miles of ash, molten rock, and hot gases up into the air. To make it easier to imagine, 4 supereruptions could fill the Grand Canyon to the brim. The Yellowstone giant was thought to be responsible for at least 3 enormous eruptions and countless smaller ones. In that region, the volcanic deposits are scattered over tens of thousands of miles. Scientists believe they had been created by many weak eruptions. But after doing more research, experts found out these deposits had been left by 2 previously unknown supereruptions. Those probably took place about 9 and 8.7 million years ago. This discovery means that the area around the Yellowstone volcano used to face a supereruption every 500,000 years. But over the last 3 million years, the hotspot has seen only 2 supereruptions. It makes scientists believe these catastrophic events are slowing down, or just maybe one is overdue. Anyway, if the Yellowstone supervolcano went off with as much power as it had 2.1 million years ago, it would spit out more than 588 cubic miles of boiling lava. That's more than 4,500 times the volume of Sydney Harbor. That's a lot of lava. Whether it's likely to happen or not is another question. There's no doubt that something is going on with the volcano. The water level changes in Yellowstone Lake mean the caldera is lifting under the surface. And the caldera is what's left over after a volcano erupts and then collapses. The Yellowstone caldera is not just going up, creating a dome-shaped uplift. It also moves up and down in a kind of breathing motion. It might be because the magma is seeping into the crust, or because this magma is heating up the Yellowstone hydrothermal system, making it expand and raise the crust. Yellowstone has the status of an active volcano. Its volcanic explosivity index is 8 out of 10. Such a high number means that if this volcano erupted, it would be an apocalyptic event. Right before the disaster, the ground around the national park would lift. Geothermal pools and geysers would heat up to boiling temperatures and get more acidic than usual. The magma would start to rise toward the surface. At some point, the rock roof of the magma chamber wouldn't be able to resist anymore, and the explosion would kick off. A massive column of lava and ash would shoot up to a height of over 16 miles. After that, the volcano would keep pumping ash for days on end. The mixture of lava, ash, and gas would be hotter than 1,800 degrees Fahrenheit. It would travel through the area at a speed of 300 miles per hour, faster than a racing car. The air near the center of the eruption would heat up to 570 degrees Fahrenheit. One of the most dangerous consequences would be ash fallout. Volcanic ash can turn into glassy cement within seconds after being inhaled and getting in the lungs. People and animals would have problems with breathing. Okay, so that's an understatement, just so you know. Buildings would start to collapse under the weight of this dense substance. It would take just several days until a 10-foot layer of ash covered the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. If the eruption was rich in sulfur, an effective sunblocker, it would get so cold there would be no summer in the entire world for the next several years. The monsoon seasons would change. Agriculture would face serious problems. There would be issues with food supplies. Over the past 50 years, the Yellowstone caldera has risen almost 2 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. The probability of the eruption is 1 in 730,000. Safe to say, it's a long shot. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. Still, there have been tons of discussions about what people could do to prevent the disastrous supereruption from happening. And the most popular and seemingly effective idea was to cool the Yellowstone supervolcano down. Unfortunately, there's a catch. The volcano leaks out only 70% of the heat which comes from its magma-filled chambers, but the rest of the heat stays inside. As soon as it reaches a particular threshold, the volcano erupts. If it was possible to extract at least 35% of the Yellowstone volcano's heat, the eruption could be avoided. The cooler the magma is, the thicker and stickier it gets. It stops being so fluid and doesn't try to get out to the surface anymore. After considering these facts, NASA scientists came up with a plan. They suggested drilling a 6 miles deep well and pumping down cold, pressurized water. The temperature of the water that would get back to the surface would be approximately 662 degrees Fahrenheit. This way, the heat would be gradually extracted from the volcano. And if a geothermal plant was built on the site, it would generate plenty of electric power. It would be very simple to produce, and its price would be very alluring, about 10 cents per kilowatt hour. At first glance, it was an amazing idea, but sometime later, it started to receive a lot of criticism. Imagine drilling through the Earth's crust, getting deeper and deeper, and then wham bam, you hit a hypothermal pocket. Uh-oh, get ready for a catastrophe. This can release gases that are likely to cause a series of super powerful explosions. In the worst-case scenario, it may even trigger a full-scale volcanic eruption. Now, you already know about its catastrophic outcomes, from fountains of lava and avalanches of molten rocks to climate changes all over the globe. Yeah, not good. Or let's say you're drilling a well to deliver cold water to the volcano, and then you suddenly hit its magma chamber. In this case, instead of cooling the giant down, you'll make the top of the magma chamber much more fragile than it used to be, and the whole construction will be at risk of collapsing at any moment. And don't forget that your drilling may also release toxic gases. They often accumulate at the top of the reservoir with magma. Can it get any worse? Well, yes it can. The whole process would stretch for more than 16,000 years. This method is too risky to cool the volcano down as fast as people would probably want. And scientists aren't even 100% sure that when the cooling system construction is finished, the volcano will stay cold for at least another 100 years. And last but not least, the project of making the Yellowstone supervolcano a bit cooler would cost a mind-boggling $3.5 billion. A huge price for something that might not work out altogether. Oh, by the way, Yellowstone isn't the only volcano that has a lava dome that's lifting at the moment. Lava domes are created when magma gets to the surface and then gathers around the vent. Scientists have found one of those inside an underwater volcano in Japan. This dome is more than 2,000 feet high and more than 6 miles wide. Even though the Japanese supervolcano seems to be sleeping, experts don't let their guard down. A volcanic system can go from being calm and docile to teetering on the edge of an eruption in the blink of an eye. Another massive dome is growing in the central Andes, on top of the planet's largest active magma store. The Altiplano Puna Plateau, well there's a tongue twister, and where the dome was found, is the second highest plateau in the world, and the dome itself is more than half a mile tall. You might wonder how come experts have known nothing about this enormous uplift until recently. The answer is simple. It was hidden within the plateau. It's an arid region littered with volcanoes, and it stretches for thousands of miles. Yep, another case of hiding in plain sight. If you've ever been to Yellowstone National Park, you were probably mesmerized by its geysers, which spew superheated water and steam high into the air. But an even more intriguing thing actually hides underground. I'm talking about that underfoot plumbing system that makes those grand eruptions possible. About that, there's good news. Recently, researchers have succeeded in mapping the national park's hydrothermal plumbing system with the help of a giant flying magnet. As a result, scientists have managed to document all these features in stunning detail. The thing is, Yellowstone houses the world's largest hydrothermal system. It contains over 10,000 features, like geysers, mud pots, hot springs, and steam vents. They're fed by a network of underground water pathways. Those get overheated by magma flowing underground. It causes the water to rise to the surface. Now, no one actually knows much about the workings of this system, but the newly created maps might finally shed light on it. Experts explain that their knowledge of Yellowstone has a subsurface gap. That's why it's often called a mystery sandwich. Scientists know quite a lot about the features on the surface because they can observe them directly. And they know what's going on in the magmatic and tectonic system several miles below the surface. But they haven't figured out what's happening in the middle yet. So, I must tell you about that giant flying magnet used for research. It's known as SkyTEM. It was attached to a helicopter and flown over Yellowstone several hundred times, scanning the ground below. The magnet is made up of an 82-foot wide charged wire loop. Its main task is to generate a strong electromagnetic field. And since different kinds of material, like water or rock, respond to this field differently, scientists managed to create a few subsurface maps for the first time ever. The mapping technique also allowed the researchers to differentiate between magma and bedrock, since they have a bit different magnetic properties. And the team got a chance to see how the magma and water interact and create those mind-blowing geological features on the surface. The team got high-resolution maps to a depth of around 500 and 2,300 feet, and low-resolution maps showing what's going on at a depth of up to 1.5 miles. At the same time, the researchers think that the hydrothermal system itself may stretch as far as 3 miles below the surface. If they're right, it means they've only mapped the top half of Yellowstone's plumbing system. Anyway, remember how I said that scientists know pretty much about the bottom part of the Yellowstone sandwich? They have such a good idea about the tectonic plates and deep fault lines because the park's frequent earthquakes provide them with a lot of opportunities to study different phenomena. In July 2021, for example, more than 1,000 earthquakes rocked the area. These days, the team of researchers knows much more about some famous features, like the Old Faithful Geyser or the Grand Prismatic Spring. They've also found out that individual hydrothermal features on the surface can actually be connected to others, which can be as far as 6 miles away from them. Another interesting discovery is that even though Yellowstone geysers and hot springs vary in size, shape, color, volatility, and chemical composition, they are mostly fed by very similar underground sources. That means that the difference between the features appears closer to the surface. Now, I'm sure you've seen the iconic image of Yellowstone with a large rainbow-colored spring, fiery orange at its edges. So what makes these hot springs so colorful? Surprisingly, these awesome hues come from microscopic creatures. The temperatures in the springs are so high they can easily and quickly cook you. Plus, the water there is super acidic, like the liquid in a car battery. But there are certain types of heat-loving microbes that don't mind these crazy conditions. You can even say they're thriving there. So every ring of a different color is, in most cases, a ring inhabited by different bacteria. And each species is adapted to a particular temperature or pH level, which measures how acidic this or that environment is. For example, take the Grand Prismatic Spring, yes, the iconic one. Its rainbow hues likely hint at the diversity of microbes living there. So, starting from the center of the hot spring, you can see a beautiful aquamarine color there. That's where the water temperature is the highest, reaching 189 degrees Fahrenheit, because this area is right over the underground water source. The water there is too hot even for microbes. That's why what you see is mostly clear water. As for the reason for its blue color, it's the same as why the sky is blue. Sunlight hits the surface of the water and the light scatters, but the blue light scatters the most, getting reflected back to your eyes. Now, the next ring of color is yellow, all thanks to certain cyanobacteria. The temperature in this yellow ring reaches 165 degrees Fahrenheit. If the conditions in the hot spring were a bit different, these bacteria would create a blue-green hue, thanks to a green pigment called chlorophyll. But since the sunlight hitting the spring is too intense, the bacteria start producing another type of pigment. It's called carotenoids. And guess what? It acts as a sunscreen for the bacteria. And since this pigment is orange, the normally green bacteria get a yellowish hue. And finally, we've got that bright orange color closer to the edges of the prismatic spring. It's a bit cooler there, around 149 degrees Fahrenheit. In this part of the spring, you can find several types of bacteria. They all produce substances that give the spring this bright orange color. And finally, right at the edges of the spring, the temperature is cooler, around 131 degrees, and a greater variety of microbes can survive there. All of them combined give the edges of the spring that red-brown hue. But scientists believe that people and their activity may have influenced the colors of Yellowstone's hydrothermal features. For example, in the past, the temperatures in the Morning Glory pool used to be much higher than they are today. That's why its color was a deep blue. But trash has started to accumulate in the pool, and some of it clogged the vent. This caused the temperatures to drop, which led to microbial growth. As a result, that pretty blue color turned into orange-yellow. As for Yellowstone's geysers, the most famous one is called Old Faithful. It got this name at the end of the 19th century because of how regular its eruptions were. This geyser is more active than the others, erupting about 20 times a day. Each of these magnificent events lasts from 1 to 5 minutes, and the fountain of steaming water can reach a height of 180 feet. Now, while talking about Yellowstone National Park, we can't but mention Yellowstone supervolcano, right? Supervolcanoes appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through Earth's surface. Sometimes all this magma gets stuck, unable to break through the planet's crust. And then, massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a supereruption goes off. You don't necessarily want to be around for that. Over the past 50 years, the Yellowstone caldera has risen almost 3 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. There have been at least 3 other supereruptions in the history of Yellowstone volcano. They happened 2.1 million, 1.3 million, and 640,000 years ago, long before video. The most recent supereruption was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spilling out 240 cubic miles of rock, dust, and volcanic ash. No thanks, I'll pass.